Hi dear students, we are going to continue with the properties of the determinant. This is the second video about the properties of the determinant, and we are going to continue with the first property here. And we are going to work again n times n matrix, which is square matrix. If two rows or columns of A are interchanged, which means that, let's say, the first row and the second row places, if you change, then you will get A prime. This is not the same matrix, you will change their places, then determinant of A prime, it should be equal to minus of determinant of A. So if you change their places, you will get the negative of A. Let's write the A prime firstly, then let's find the, or let me write the A prime here. Let's interchange the first row and the second row. Let's say here this is 2, 0, 1, then 1, 2, 3, and 1, and minus 1 and 2. What is the determinant of A prime? Determinant of A prime, then let's find determinant of A prime, and let's find then here determinant of A, and let's see what are the results. Okay, here firstly we have to select one of the row. I'm going to choose the first row here, and in both of the question I'm going to choose the first row. So if I choose this row, the determinant of A, it should be like this. Here 1 times minus 1 to the power of 1 plus 1, first row, first column. Then the minor of this part, which is equal to 0, 1, and minus 1 and 2, it has to be. Then plus the second entry is 2, then times minus 1 to the power of 1 plus 2, times the minor of the matrix is 2, 1, 1 and 2 here. It's going to be 1 and 2. Then the last one, it's going to be equal to 3 times minus 1 to the power of 1 plus 3, first row, third column, times the minor when you close first row, third column, 2, 0, and 1 and minus 1, it's going to be. Here firstly I'm going to say this power is even, so the result is going to be positive 1, which is equal to 1 times 1, it should be equal to 1. Here it's going to be equal to odd, so that this is negative 1, so it's going to affect like minus 2 here, minus 2 times, and here it's going to be equal to, this is going to be equal to, actually here, this is going to be equal to minus 1 to the power of 4, which is positive, it's going to be, and 3 times 1, it's equal to 3, it has to be. Then let's continue here. 1 times the determinant of this matrix we are talking about, 0 times 2 is equal to 0, minus 1 times minus 1 is equal to minus 1, it has to be. Then here the minus 2 it's coming, then times the minor of this matrix, it's going to be equal to 2 times 2 is equal to 4, 1 times 1 is equal to 1, so 4 minus 1 it has to be. Then this is going to be plus again, 3, 2 times minus 1 is equal to minus 2, 1 times 0 is equal to minus 0, so this is the determinant of the matrix, it's going to be 1 times 1, 0 plus minus minus 1, it's going to be 1, plus 1, minus 2 times 3, and plus 3 times minus 2, it has to be, which is equal to 1 times 1 is equal to 1, minus 6, and here 3 times minus 2, it's going to be equal to, minus 6 also. So the answer is 1 minus 6, which is equal to 1 minus 12, which is equal to minus 11. It has to be. Now I'm checking the here A prime. What is the determinant of A prime again? And I told you I'm going to do like this. Firstly, I'm going to use the first row again, and in the first row the second column is entry is 0, so it's going to make operation hour easier. 2 times minus 1 to the power of 1 plus 1, first row, first column, times when you close first row and first column, the minor is going to be equal to 2, 3, minus 1 and 2. Then plus 0 times minus 1 to the power of something, it's going to be here 1 plus 2, but whatever you are going to write, this is going to be equal to 0. Then plus 1 times minus 1 to the power of 1 plus 3. 1 plus 3, this has, I need space here, that's why I'm going to write smaller. 1 times minus 1 to the power of 1 plus 3 times the minor, it's going to be equal to, here when you close first row and third column, the minor is going to be 1, 2, 1 and minus 1, it has to be. So since this part is 0, I'm going to cut that one, and here this is going to be positive because the power is even, so that's going to be equal to 2. And this is positive again, power is even, so the here multiplication result at this part, it's going to be equal to 1. Then I'm going to continue with the 2 times the matrix. Here 2 times 2, 4, minus 3 times 1 times 3 is equal to minus 3, but since there is minus and minus, it's going to be plus 3 later. Plus 1 times here, 1 times minus 1, it's equal to minus 1, it's going to be. Then 1 times 2, it's going to be equal to minus 2. Then that's going to be the answer of this part. Here 2 times 7 plus 1 times minus 3, it's going to be, which is equal to 14 minus 3, that's going to be equal to 11. As you see, determinant of A is equal to minus determinant of A prime. Okay, let's continue with the other property. Like it is fraction. If you do here fraction sign, the denominators are going to be same. You are adding them only one row, which means that here, when you have the second row and third row same in two different 3 by 3 determinants, you are only adding the one of the row, the first row, which are different to each other. We can also summarize like that. So if we solve this question here, 165, 187, 167, 188, what is the determinant of this matrix? If we are looking for 165, 168, and then this is 165 plus 2, 165 plus 2, and this is 187 plus 1, it's going to be. Here, this is the first question now, and you're going to keep the row here same, which is equal to 165, 187, and then plus 165 and 187, because there is no addition here. But the second row here is which is added. Here we are going to write 165 here 2, and here 187, and here plus 1, it's going to be written here. Since this matrix, as you see here, the rows and the columns, they are equal to each other, which means that if the rows are identical to each other, then the determinant of this matrix, it should be equal to 0. So this is 0 plus 165, 187, 2 and 1 it should be. Then, the result of this matrix, it has to be 0 plus 165 minus 2 times 187, it should be, which then it's going to be equal to 165 minus 2 times 187, it's going to be equal to here 300, if it is 180, 190, I'm sorry, 190 times 2, it's 380, it's going to be minus 6, it's going to be equal to 380, 376, I'm sorry, 374, I'm sorry, 374 it should be. So when you subtract 365 from 374, or minus, it's going to be, since it is bigger, and the answer is going to be 200 and minus 209 it has to be. To continue with the third one. In the third one here, we are going to, in the third property, for the square matrix, each element in one row multiplied by a real number k, then the resulting elements added to one of the corresponding elements of another row or column. It's same for row and column. Then the resulting determinant is the same original one, which means here summary as a summary, this is row operation. If you do row operation in this matrix, the resulting determinant, it's going to be same, which means here, let's say here the determinant of this matrix here, it's equal to 1, 1, 4, 1, and 2 minus 1, 0, and 0, 18 and 4. Let's choose another matrix, but this matrix we are going to generate from this matrix, which means that I'm going to multiply them to make the one of the rows column 0 here. This is the way also to do these operations, because if you make one column 0, it's easy to calculate the determinant. I'm going to explain also how it is. And firstly, minus 2 times R1 plus R2 is going to be equal to new R2. This is the row operation, and this matrix, it's going to be B matrix, and here in the first row it's not going to change, 1, 4, 1, and the second row it's going to be equal to 0. Here minus 9 minus 2 times 1 is equal to minus 2 times 1 is equal to minus 2, plus 0 it's equal to minus 2 it should be. Then here 0, 18 and 4 it's going to be. So this is the B matrix, but we get this matrix by using the row operation as I explained here. Here I'm going to find the determinant of this matrix. I can use any row that I like, but I'm going to use the second row again because there is 0 here. I can use the third row also, but I'm going to use the second row now. Here, if I shade this part, the determinant of A is equal to determinant of A, let's write with green color, 1 times minus 1 to the power of 1 plus 1 times, here it's going to be equal to the minor of this part, minus 1, 0, 18 and 4 it's going to be. Then plus 4 times, I said I'm going to use the second row, but I used the first row, sorry for that one. 4 times minus 1 to the power of 1 plus 2 times the minor, it's going to be equal to 2004. But that's going to be equal to 0, so that's going to make it 0 also here. And then plus 1 times minus 1 to the power of 1 plus 3 times, and here 2 minus 1, 0, and 18 it has to be. Okay, if we calculate this one, here determinant of the A, it's going to be equal to A. Determinant of A, this part is equal to positive 1 minus 1 to the power of 1 plus 1, so 1 we are going to get, then minus 1 times 4 minus 4, minus 18 times 0 is equal to 0, then plus 4 times, actually this is going to be minus 4, I'm sorry for that one, this is minus 4, minus 4 times, because this is minus negative, minus 4 it has to be, then 2 times 4 it's equal to 8 minus 0 times 0 is equal to 0, it has to be, the last one Again, positive 1, it's going to be plus 1 times 2 times 18, 2 times 18, which is equal to 36. 36 minus 0, it has to be. Here, it's going to be equal to minus 4, and 1 times minus 4 is equal to minus 4. Minus 4 times 8, this is 1 times 36, 36 it's going to be, which is equal to minus 4 minus 32 plus 36, which is equal to 0. Here, this is the determinant of A. And here, determinant of B, I'm going to calculate. Actually, determinant of B, it's going to be equal to 0, because here, as you see, when you multiply the second row by 2, you're going to get minus 2. You're going to get the third row. So if you remember from the previous video, if one of the row is multiple of another, the determinant, it should be equal to 0. Or we found that here the A matrix and B matrix, which is B evaluated by the you evaluate the B by using the row operations. So the determinant of the matrices, it's not going to change.